Hi everyone, in today's lesson we're going to talk about how we can multiply with trigonometry. We're going to start by using the distributive property, something that we're most familiar with. So the distributive property would be something like 2 and then x plus 7, right? You would multiply 2 times x and then you would multiply 2 times 7 and you'd be done. And I want you to see that this thing here to the left is the exact same thing. You're going to multiply the secant times 1, and that's just secant of theta. And then we're going to multiply secant of theta times sine squared. So it's just secant of theta sine squared, right? That's the distributive property. And if we want to, we actually can simplify this. So let's simplify secant to be 1 over cos. And again, another 1 over cos. And we know that these two are being multiplied together. So sine squared of theta is just sine squared. You can put it over 1 just to show where it belongs. And order of operations tells us we multiply first. So this fraction, tops with tops, sine squared over cosine theta, right? This times this is sine squared. This times this is cos. And then leaving the 1 over cos as is. And then the denominators are the same. So 1 minus sine squared theta all over cos of theta. Now, if you remember from yesterday's lesson, we should remember the Pythagorean identity. So 1 minus sine squared is simply cosine squared. And cosine squared theta over cos is simply cos. Why? Because there's an extra cos on top. So this is cos, and this one cancels to 1. Now, some of you might have noticed something a little bit easier from the beginning. So I'm actually going to cross this example out, and we're going to do this one over again in a more simplified way. We can do this without the distributive property. We could theoretically see that this is 1 minus sine squared, and that gives us cos theta, cos squared, and we're going to multiply that by secant. We know that secant is 1 over cos, and we know that cosine squared is just cosine squared over 1. Any number can be written over 1. I can cross simplify here. This one cancels with this one, with the leftover cos on top. So the final answer, 1 times cos is cos, and 1 times 1 is 1. So some of you must be wondering, why did I show you this way second and then this way first? Well, there's definitely going to be multiple different ways to answer these questions, and I want you to see all of the different options. These are like puzzles, right? So there's always different ways to do them. There's not always one answer. If you saw distributing first, this would be your approach. If you saw the Pythagorean identity first, this would be your approach. All right, let's see what other problems we have. Multiplying using double distributing. So when I have two binomials multiplied together, we're going to double distribute. So 1 times 1 is 1. 1 times sine of theta is sine of theta. Sine of theta times 1 is another sine of theta. And sine of theta times sine of theta is sine squared theta. Remember, x times x is x squared. These two are like terms. So 1 plus 2 sine theta plus sine squared theta. That will be our final answer. Now, if you're having trouble determining when to put 2 sine of theta and when to put sine squared, it may help if you consider writing this like this: 1 plus x and 1 plus x, where x is your sine of theta. When you double distribute, 1 times 1 is 1, 1 times x is x times 1 is x, and x times x is x squared. So just like we did here, our sine squared stayed the same, so does our x squared. Our sine plus sine is the same thing as saying x plus x, so that's 2x, so that's 2 sine. So when you're multiplying them together, it becomes squared, and when you're adding them, you just add them just like you would x's. So what I'd like everyone to do right now is try this next one on your own, and then hit resume when you're ready for the answer. Okay, so when you double distribute, you get 1 plus cos theta plus cosine squared theta. These two add together to be 2 cos theta bring down your cosine squared and your 1. Very similar to how we did this one. All right, let's go to the back. We could multiply binomials that are called conjugates. Conjugates are simply binomials with different middle signs. So 4x plus 5 and 4x minus sine 5 are conjugates because their middle sign is changed. Same thing with 2 minus x and 2 plus x. The middle sign is changed. So take a couple minutes, pause the video, and double distribute both of these. And then hit resume when you're ready. Okay, so for the first one, this is what you should have gotten when you double distributed. And what you should have noticed is that the middle terms of negative 20x and positive 20x will cancel. And that'll also happen here. The positive 2x and the negative 2x will cancel. So our final answer, 16x squared minus 25 and 4 plus x squared, both have what's in common is that these middle terms are canceling. So is that always going to be the case for any time we're multiplying a binomial with its conjugate? And it will, right? These middle terms are going to cancel because these signs are opposite. So if you know that you have a conjugate pair, you can avoid this middle step altogether if you want. All you would have to multiply together are our first times first to get me the 16x squared, and then our last times last, 5 times 5, or negative 5, to get me the negative 25. So same thing over here, first times first, and then last times last. The 2 times 2 gives me 4, and then the negative x times x gives me x squared. Now again, this trick of only doing the first times first and last times last only works when you're multiplying conjugates. So let's take a look at trigonometry now. We're going to multiply by double distributing. 1 times 1 is 1. 1 times negative sine of theta is negative sine of theta. Sine of theta times 1 is sine of theta. And sine theta times negative sine theta is negative sine squared theta. Remember, x times x is x squared. So similarly, like before, these middle terms cancel, and you're left with 1 minus sine squared. Which you should remember, that's a Pythagorean identity. So 1 minus sine squared is cosine squared. All right, let's try the next one. I'm going to do it the shortcut way. First times first is 1. I know that this and this are going to cancel, so I'm not even going to write them. Negative cos times positive cos is negative cosine squared. And again, a Pythagorean identity, 1 minus cosine squared is sine squared. And that's it. That's my answer. So today's video was really, the whole point of it was just to get ourselves comfortable with multiplying trigonometry together, knowing when you can add, when you have to raise an exponent, things of that nature. So make sure you write down any questions that you have and definitely ask me in class tomorrow. All right, have a good night.